Let me know when you guys are seeing my screen.
I'm able to see, sir.
Yeah, okay, all right. So see, the goal is basically to build a microservice architecture like this with different components in it and different microservices present in it. But we can't build all these things in just few hours because everything is quite intensive. So what we will do is we will first understand the essence of what microservice is, and then we will build one microservice in this class. And then there will be more sessions in upcoming days where we are going to extend this example, and then we will build the complete microservice architecture. We will also learn how to deploy them using some containerized solutions like Docker, Kubernetes. But then you have to start from somewhere, right? So this is the class where we'll start building the microservice. And what is the use case that we will take? You can take any use case, but we are going to take an use case of a bookstore application. But you are free to do this with any other use case, e-commerce application, a banking application, an onboarding system, whatever is your requirement. To make things simple, we'll use this book author system where you can add different functionalities like placing orders for the book and other operations. So we will dive into it. So again, let me quickly summarize what we are going to do. So if you say this is your microservice architecture, which has lots of components like API gateway, then you have this something called service discovery or discovery service. You have config server. You have other components like histories for monitoring and other things. And here are your microservices, microservice 1, 2, 3, 4, 5. You can name it and that many microservices you can have. But all of them interact with each other, not directly, but there are different ways that they interact. And while interaction also, there are other patterns that comes into picture like circuit breaker pattern. So the thing is this microservices, individual components will be divided, decided based on your use case. What is the functionality you are building? In our case, we are going to build a bookstore application. So one microservice can be related to book and author. Another is for browsing all the books available in the application. Third could be placing an order of a particular book. Fourth could be checking the inventory for that particular book. And fifth could be, let's say, other things like you can do other operations like profile or changing details of your shipping address, those things. And these components that you see about microservices, they always remain constant. API gateway, discovery service, and these things. So today we are going to build one of the component, one microservice. If we'll know how to build one, we can build any other microservices component. And then of course, in future, we are going to learn how to build these components also. And finally, what we will do is as I would say, maybe a bit more in future, we are going to deploy all this as containers, all these microservices containers in a containerized solution, let's say Kubernetes, which is the popular one. We will deploy it, let's say, in the local environment. But We can also deploy it on any cloud solutions like AWS, Azure, or Google. And of course, there will be CI/CD process for each of them. But then you need to start from somewhere, and this is where we will start with this component. So this is the use case that we will build. If we see this book author system, it's a book application where there can be many authors. Authors can register on the system. Author can log in, log out, and author can change their profile information or personal data. And there will be also something called book as one of the entity. So each author, whoever is writing a book, can create a book instance on this application. So one author can have many books. Similarly, there can be other functionalities. There can be a customer also at this end who can view all the books and maybe view a detail of the book. The same operation can be performed by author also. They can view the book. Author can view only his books because it doesn't make sense author views other people's books. Of course, he can do via customer. And the search, author can search one of his book, and customer can search books from all authors. Author can do update of the book details or delete a book from the system. And the customer can place order. All kinds of operations can be performed. So we need to understand first how we can design these kind of small systems, because microservice means individual component. You don't have to put all the entities of your application in one system. Order can be a separate one. Search can be separate one if you want. Inventory can be separate. And this, let's say one we will have for the book, where all the operations related to book will be happening. So now we are going to see how we will build this, right? This is very important, how you build this microservice component. So of course, we will use something called as RESTful web service. It stands for representational state transfer. So here what we do is we build an application in such a way that when we try to talk to this application, the application responds to us, but the response is not something as a website, as a HTML markup or CSS or JavaScript, but this response itself is coming in a format called, either it can be in the XML format, we will see what is that, or it can be in the JSON format. We are going to also see what is that. So this way of building something on internet is called web service. The word itself says something on the internet you are building and can be used as a service by others. So web service. So how is it different from a web site? That's very important to understand. We also have web site. So if I go to this page, which is this, of course, the course enrollment page, you see when I hit this URL, it gives me data, but it also gives me how the data is aligned, like this menu, image, button, tags, and this is my data information. And it also gave me how the information is displayed. So if I click on view source, I will see data coming in the form of HTML. My data is embedded inside the HTML. You see this? So if I look for, let's say this one, this line, This line will be there. It's here. But then this line is surrounded with so much of HTML markup or text. So can everyone go on mute, please? If you have questions or doubt, just raise your hands or just unmute yourself. So we saw how a website, when requested for a page, gives us content along with the style of how we want to show. But can I take this one and build a mobile app from this? Can I use this data and build a mobile app? Or can I use this data from this website and show it on another website? That's not possible because this data is coming in a different format, right? So that's where the role of REST API comes, web service. What web service does is when you request a particular URL, it's not going to give you data with how to show the data also. It's not going to give you the styling or the HTML part. What you will get is a raw data. It's up to you how you design your system and show that data. So let's go to this website. You see, this is a website. This website or this a small application will also have data coming. So let me show it here. And if I type here, let's say Harry, and if I click on this search, this page did not refresh because there's a single page. And then this view got loaded. You see, different movies related to the word Harry got loaded. But from where did the data came? If I click on this, you see there's this data which is coming. And the data is coming in this format. And I have decided to show it in this view like this. But then if I wanted, I can show it in this view also, like a table format, these things. So now what we are seeing is the data here is not having the HTML or CSS or other kinds of information, which means this is just a data available in a certain format, which is of course called JSON, JavaScript Object Notation. And now I can develop an application, whether it's a website who can consume this data. I can also develop a web application who can consume this data. Like a mobile app also I can develop because this data is independent of how it should be shown. So I can develop any kind of client application. Even I can call this data from one of my microservice Spring Boot because it is very simple and I can consume it and then I can decide how to show that information on my website. Can all of you, can Masum go on mute, please? Or let me do it from here. Yeah, okay. So I hope now you understand what exactly is the difference between a web site and a web service. And because this web service is providing us data in a format which is very simple, it is independent of any client-side technology. So I can develop mobile apps using Android, iOS. I can develop a website. I can develop even a chatbot can call this web service. Even my other microservice component can call this web service. But in case of website, it was not possible. But does that mean there was only one way to create web service, REST? No. Before REST, there was also another way to create web service called SOAP. But we are not going to jump into that. SOAP is another format in which you can expose a simple application as a web service to the world. So now that we understand what is the difference between web service and website, and we know that we are going to build web service using REST standards, which will then it will be called RESTful web service. And I've already shown how a RESTful web service looks like. If I open this link on a different tab, you will see this as this web service is available on this website with this URL, and there's some API key and other things. And this is giving us this data. If I change it here to something else, that's a Tom, then I will get a different data. And now I build an application which will show me this information like this. So if I type here Tom, hit enter, it shows me all matching keyword for Tom. And this time it made another call and it fetched the data using the Tom keyword. It fetched all the movies like this in that format. And I showed it this way. What if I click on a particular movie? So it makes another call like this to fetch only the details of the movie. Let me open this. You see, this is only one object. So it gave us a lot more information about that single movie. And now it was up to me how to show this. So this is how I displayed it. I kept the image here, which is coming from here. If you see, this is the image of the movie. So poster. If I open, I can even open it. So this is the image which was embedded there, the image URL. And then the title was the movie, then genre, this, all this is coming, and I decided to show it like this. I can also click on the link and go to IMDb to show its detail. So visually, how I want to show the data which is coming from my website is now independent. And each service is now a web service because RESTful web service, because while by hitting the URL and passing different parameters value, our backend, in the backend, there is a service running which is querying the database and giving us that data. So now we know why it is very important to have this kind of information. So if there are different use cases which we are seeing in front of us, like from Google, you can book Uber cabs. How is that possible? Inside the Google apps, you can integrate or call APIs from Uber, and then you are able to provide that functionality in that. So different applications belong to different companies, and each of them are compatible with other. That is because of this capability of APIs, REST APIs. So now we understood how the APIs are existing, their importance, what do they do, and how they form a microservice architecture later on. But this is not our goal for now. We are sticking to this part only. In upcoming classes, we will cover them. So here we are now. We are making a call to a service, which is a REST service on internet. Right now, we are making call to this service, which is OMDB API, and it is giving us data in JSON format. But I can also request data in XML format. But XML has a disadvantage that it always have a opening tag and a closing tag. Hence, JSON is the most preferred format to exchange data because it is very simple. It doesn't have an opening tag and a closing tag. It just has a key and a value format with a comma and again key and value, comma, key, value. But if you look at an XML, there will be an opening title tag and a closing title tag, and in between the data will be there. But then if for every tag we will have an opening and a closing tag on the network, on the internet, it will take more time for loading that information, because it also has to parse and send the closing tags for each of the attributes. So now very quickly we will go and touch upon some of the important things about web services. So we are seeing that when we are hitting from any client, whether it's a laptop or with a browser, or mobile device with an app, or even from the television, we can request a URL for a certain data, and there will be a server application which is running in the background. We don't know what is this application which is giving us this data, whether it's a PHP application, .NET, Java, or even a microservice architecture in Java, or just a Node.js application, or a Python-based Flask or Fast API. We don't know, and we don't have to know, because what we are worried about is when we call this, we should get the data. We should just know how to make the right calls. If we pass data in a separate variable, we may not get the information. So if I make this mistake, let's say instead of API key, I do API key 1, it will not give us the data, because the format has to be, we have to stick to the format. So it's API key, not API key 1. So that is what how this backend application is built. So you can build this backend application, the whole microservice architecture, in one technology, or you can mix all the technologies. It's up to you. So what is web service? Web service, we saw, isn't basically a way to interact between different services in such a way that the response is something which is not HTML. It can be parsed. So and REST service is called representational state transfer, because when you request something from here, the server responds with that data specific to your request. So what is happening, the state is getting transferred over internet based upon what you are requesting. And again, the REST services can be in the format of exchange between the client and the server can be in two ways. One is the JSON and XML. So here, there's a little bit of detailed picture. The client requests the server for data in the form of JSON. And then there are different ways it can request data. And those ways are defined by this HTTP protocol. So here, this HTTP protocol says, okay, if you want to exchange data on internet between different application using REST standard, then you need to stick to these methods: get, put, post, patch, delete. So if you see here, if I show you here, what is this request being made? If I click on the headers here, you will see this request which we are making is of method type get. So when you request something from the server, the method you use is get, because you just need some data, or you are querying some data, or you want to some just read only kind of thing. So you use get methods there. But let's say you want to create something new on the server. Let's say for our example that we will build, an author creates a book, which means author has some information which he has a lot of information: book details, book name, book genre, book category, maybe book price and book description. Lots of information he has. So here he needs to send the data to the server, so that the server here should save the book information in a database. So for these kind of scenarios, you should go with a post method of HTTP protocol, where the new resource will be created. And let's say if our author wants to delete a resource, you should use delete method. It does not mean that you cannot use post method to do delete. But if you are doing that in terms of IT standards or industry standards, where you are working in your company, that's not a good practice, because you should follow REST standards. And REST standards are very strict. When you want to just get information, use get. When you want to delete, use delete method. And when you want to send some data and you want some data to be saved into the database, use post. Similarly, there are other methods. Let's say put. Put is an if you want to update one or more fields of your resource, use put. Let's say you want to only update partially that data, use patch. And options is basically it helps you give some summary about your API calls that you want to make in future. But then here we will most of the time we just focus on building this using this methods to build the APIs. So here again the client is going to make the call one of this using one of these methods, and this particular call will be just in the form of a URL, and this URL will be mapped to a particular method in the server, and that method or functionality can be written in any technology. We are going to see that, and once the server and because now it's about just let's say there is an add method here, add to numbers method logic is written, so you can call from here my server slash add to methods and then pass the data to numbers from here. This server will that add method will get invoked, whatever logic is present it will get executed, and it will respond you with the data. So what it means is every logic or method or functionality that you are writing on the server can be linked to a URL. And if anyone knows the URL as a consumer and knows what is the URL taking as input, can call that API or service very easily. Like we knew the book service, so we are able to call it. So this is how it works. But HTTP also has some other things. Of course, this is about the how you form the URL, like you have the protocol itself, and then the name of the service, resource, and the resource ID. We are going to see that. Let's say in this example, you have this post method where you want to create a client wants to create a new tutorial on a server. So the API URL can be anything, but there has to be a format or a standard again that needs to be followed. So here it says for post, it should be API tutorials. For get API tutorials, you can have same URLs. And for getting a detail of one particular tutorial, you can have like this format. And again, as said, this URLs can be mapped to methods which are written in different technologies. We are going to see that when we do the hands-on. And here we have the HTTP status codes. So one thing we saw is that HTTP protocol has methods, but it also has codes. There are many codes, but you don't have to know all of them. Some you should know. Let's say 200, it means something you wanted to do and it was done successfully on the server. Similarly, if something gets saved or created on the server responds with 201. But we say server responds with, but it is the responsibility of the developer to make sure this you return 201 when something is getting created. Similarly, if something is deleted, you say 204. And if something is not modified, nothing is happening, you say this. And if the request which the client is passing to the server and the server is not able to understand, you server can respond with 400. So if we are passing like this something here, server does not understand this. So at this moment, server should respond us with 400 as the status code. And where can you see the status code? So here itself, when the API calls are happening, here you can see the status code, and these are HTTP status code which are coming from remote server. And here in this case, the remote server is this website. Where is this? This website, OMDB API. So all that we are just talking about OMDB API, we is relevant to what we will build. And similarly, there are other status for unauthorized users and other things like 401, 403, and something is not found on the server can respond with 404. So this was about the HTTP RESTful web service, the protocol and the protocol methods and the status codes. If we dive a little bit deeper into the standard or the exchange method that happens, so the client can send their data to the server in the form of JSON or XML, like here it's done. And then the server can also respond that as a response in the same format. So now using this JSON or XML, it's the responsibility of the client to now parse it in the way and show it in a different way. So like see, you'd see this the same JSON can be shown like this or it can be shown like this. It's up to us. Or in the mobile, it can be shown like this. The UI part or the styling or the view part, it's up to the client how they want to show. But because the client, if the client is just a, let's say, a front-end web application like this one, the front end understands JavaScript, the browser understands JavaScript, and this data which is being returned is also JSON, and JSON is nothing but JavaScript object notation. Hence, this data is automatically getting rendered or parsed in the browser. But if I have to use this data or call this service from my Spring Boot application, it will not get passed because Spring Boot is built on, I mean, it understands Java. It's a Java related technology. So for making Java understand this JavaScript object notation, we need to do something else. We need to have another way. So there are different clients available. We use let REST templates, Fin client or web client, and then that those clients response with the information which is received from the server. Those clients are making sure they get converted to equivalent Java variables, these data. So that is called parsing of the information. And in a microservice architecture, we need to do that more often. This parsing and unparsing of the data, we need to do that because all the applications talk to each other. So again, if we scroll down, we see XML looks like this. Every tag, there's an opening and a closing tag here. So, and JSON looks like this. If I create an employee object in XML format, it will look like this. But if I create the same thing in the JSON format, it looks like this. So if I send this on the internet, and if I send this in the internet, this may take around, let's say, 50 bytes of information or 70 bytes of information. But this will only take 20 bytes. So which will be faster? Of course, the JSON way will be faster. Hence, the JSON became popular. So of course, you can represent a JSON. Let's say this is the list, employee list. You can represent it into equivalent Java class also like this. Because if JSON is not getting converted to Java and Java is not getting converted to JSON, then we have a problem. Because JSON is a client-side technology, which is JavaScript object notation, and Java objects are server-side. So there has to be a parsing mechanism between the two. So there are different ways we can parse, but Java provides libraries for that. So let's say this is a Java class and we want to convert this data that we see in a JSON format. So if you copy and run this application, this particular code, it will end up with this particular data output. So you created from a Java, you created JSON. Similarly, we can do vice versa. So in this way, you can basically have the format in which we want to exchange data between clients and server. So we saw what is RESTful web service, the importance of it, the different um, things involved like methods and protocol, methods and codes. And we also saw the format in which the clients and server or different application talk to each other on the internet using RESTful web service. So now coming to our case, what we are going to build. So in any organization or company where you are going to work or you are working, whenever there's a requirement about building a system, you need to first design that system. So if we go to our course structure also, we just covered this and this. So now we need to understand the system design and the database design. If you don't understand these things and you just design your system and build your application may run for smaller workloads or smaller traffic. But as your application grows in terms of traffic or consumers and also in terms of functionalities, there will be a lot of problems that you will see. So it's very important to decide what will be the different entities in your system and how will your system talk to each other. So the overall system design, you can do something like this. You know that there will be 10 functionalities in your application. Let's say if it is an e-commerce application, there can be 10 functionalities. So you have to decide wisely which of the functionalities which will go to which microservice and how many microservices will be there, because microservices just don't have advantage, they also have disadvantage. Let's say if there are 10 functionalities, let's say products and then inventory, checkout, cart, order details, placing order, similarly 10 functionalities. And if person A decides to use 4 microservice to build this application and person B decides to use 10 to build this system. So person A might come to a situation where there will be a problem that these developers who are working on these 4 applications will more often collide with each other's code and will mess up the overall system, or they are dependent on each other waiting for a feature to be developed and released so that other can work. But if person B breaks it to, let's say, 10 components for 10 functionalities, then person B might run out into a problem that its developers are able to nicely work each functionality because all the components code base are separate. They can work nicely. But person B may run into issues like this. Here the cost, let's say, per month is, if you deploy this 4 components on a Kubernetes cluster, person B might be getting let's say $1,000 per month as a bill, but person B might get $2,000 as the bill because he has to run more components. He has to have more database consumption and more number of pods that will run in the cluster, Kubernetes cluster. And also person B may run into problems like there will be many network calls now between different components. So the overall response time which the end customer will see via the API gateway will be very high. So you need to very wisely understand how will my system look like so that there's a balance between this and this. So maybe you decide to only build 6 microservices to develop this functionality of your e-commerce, and 6 microservice. With 6 microservice you can achieve this also, the developer freedom or independency, and also less cost, less latency due to network calls and other aspects of it. So it's very important how you design your system. Microservice architecture is very fancy and it's a buzzword, but it also has its own disadvantages and traps. So system design is very important, and this should happen right before you start even writing a single line of code, because writing code is the easiest part. You can write a lot of code and you can put them in different microservices, you can build it. But what happens after this goes to production, or it runs on a real environment where tens and thousands of users are hitting this application. What happens to your cost? What happens to your performance? What happens to your security? What is your data? What is your developers' independency while they're working in Agile, Scrum, or DevOps environment? You have to think all those upfront. So, as an architect, it's the job of the architect to think along how should the system be designed so that if there's new features also coming in future, let's say there's a new feature, the SMS and alert notification feature that is coming, so it should be easily added to one of this microservice, or a new microservice can be created, so instead of 6 it becomes 7. So that's another advantage if you design it properly, that you have the flexibility that a new component can be easily added to the existing system without impacting the existing system. So now we understood about what is system design. Similarly, we also have to think of the database design. So here we see there are three actors: customer, author, and book. In fact, yeah, there are three main components. On top of it, all the functionalities are decided. So now for the same system, there can be two scenarios. One is you can create one entity called user and name it as role author and name it as role customer. So you can build a role based system by creating one user and just create another entity called book. So user and book. And based on role, either that user becomes an author or becomes a customer. Or you can decide to have it in another way. You can say there will be an author, there will be a book, and there will be also a customer. So there will be three entities. So the way you design your system should be in such a way that how is your application going to cater to all the functionalities that is being described by the business. So if they want something like a role-based system, so go for this model where you just create a user and a role and a book. And if they don't want role-based, just go for this model. So and then of course you need to be wisely also thinking what will be the number of different fields that you should keep in author, because author is a person, and what are the different things he as a person should have? Of course, he should have his name, he should have his email, phone number, and he should also have the list of the books that he has written or published in the past, and maybe he also has some ratings and other things. Similarly, book. What can a book have? Book has its own book code or whatever ISBN number. It should have a price per quantity. It should have the book title, book description. It can also have a review. So all these things you have to decide upfront what are the different fields your entities will have and how will they interact with each other. Then you basically go and design the functionality in such a way that it's loosely coupled. And that's where we call it as layered architecture. So when we are building a big system, we need to understand that in future, if we want to add something to this system, we should not be blocked. So we can write the whole code, all this code, I can keep this class, this class, this class, and the functionality of making API, writing business logic, all database query, all this I can keep in one class. Just call it as book main.java. That's it, done. But just imagine what will happen after 1 year when this will become big, this application will become big. So writing all the code in one file is never wise because you cannot even also test it. All these components that you will build in your microservices architecture, you also need to make sure all these are individually testable with unit test, and they are also testable as a complete system as with integration tests. So you can use JUnit for unit test, and you can use, let's say, Karate, which is one of the popular framework for integration test. So if you have components broken down properly, you can write better test. Better test means less bugs in your production application, and it is performing better. And in future also, if new features are getting added, you have a better test suite. You can do an regression test using your integration test scripts, so that you are assured that adding a new functionality is not breaking the existing functionalities. So all these things should be kept in mind while developing your application. It's not just you went ahead and build a system, you are not thinking about the future. That's not allowed at all. Hence, this layered architecture becomes very, very crucial. So you can, sorry, you can have any number of layers, but then there has to be basic some division that you must have. So let's say here you have a controller layer where you say this is the layer which will be responsible for getting the request from the client and responding back with the data. So let's say when we do hit this, so this request which is going in this variable I and API key should be intercepted by this layer. And that is the job of this layer. That's it. Then there should be another layer like the service or the business layer you can call. This layer should be doing the functionality of the business logic. And what can be one of the business logic while adding a book? Of course, your business will provide that functionality, but in very simplistic term, while adding a book, you don't want to add the same book again and again. Otherwise, your database will have tons of duplicate books. So one of the business logic is avoid adding duplicate books. So where are you going to write that? Write that business functionality in this service layer or business layer. Next thing is there can be a situation that the data that you are responding back to the client or the client is entering in its request, the number of fields are different compared to what you are storing in the database. So in those scenarios, you must have entities created, which are just Java classes with variables and the getter setter functions. And those entities should work on the database and the repository layer. And you create DTOs, which is the data transfer objects for the controller and service layer. But now the DTOs is a different data type, and entity is a different data type. In Java, every class is a custom data type. So book DTO is a different data type and book entity is a different data type, which means if I just create a book, a DTO equal to new book DTO, and I create a book entity, entity equal to new book entity, I cannot do DTO is equal to entity. I will get a compilation error. So I need to convert each field of book DTO into each field of book entity and vice versa. So those conversion we should do in a layer called converter layer. But there are also nowadays smart ways to do this, which we will see when we will do hands-on. You don't have to do one by one, line by line conversion. So here, book service, book controller will call book service will call converter to convert the DTO into entity, and then the converter will respond the entity back here, and then the service should call the repository, and with that particular entity, and the repository should save that book into the database. But if you want to add a business logic here, so what you what you can do, when you got the book DTO from here, take the book title, which is let's say a unique, and search in the database with the title if the book with that particular title exists. If it exists, Here in the book service, you will get that it exists. Then from this book service, throw an exception or error to your controller, and then the controller should respond with that error to the user that you are trying to create a duplicate book because there is already a book existing in our system. So either you can apply traditional try catch, but as we are using Spring Boot, so you can go with the AOP way of handling error, which is controller advice. And if let's say the book does not exist here, you can go ahead and make the call of adding the book into the database. So this was just one functionality that we represented in a sequence diagram like this. You can This was the functionality which we just represented. You can create similar sequence diagram like this for viewing a book, viewing all books for a particular author, searching a book, updating, deleting a book. Same way you can create sequence diagram for this customers from the customer's perspective. So here, let's say ordering a book is an example. This is the sequence diagram. So this can be a separate microservice again. So remember, without this diagrams also you can build the whole system like this application. But then what happens when you are in a scenario where there are almost 50 to 500 microservices running in your application, in your overall system, then you need to have certain amount of diagram or representation which can simplify things for you. And we should not always forget it's the developers who is building the code. So they should have a clear understanding of which layer, what, how it's called. So you will see architects also drawing these kind of pictures where it makes life easier for the developers to understand and translate them to code. But it does not mean that in every project, in every company, you will find this. Unfortunately, in most of the companies, you don't have these things. So what you have to do is you just have to see your requirements, which is in Jira or any other tool, and you have to start and just understand that functionality and start translating into code. And there's something also called as class diagram, because now you need to also understand what are the different fields that will exist in this classes. So that you represent with the help of class diagram. So let's say here's an example of book. So here you can see the book will have a book ID, name, descriptions. All these all will be private fields. So you represent with minus here in front of it. And here you say with a colon, what will be the data type of it. So long string like that. And there will be also some methods in this book. So you represent with a public plus sign and the return type of this method is with a colon on this side. So this is how you can draw class diagram for your different classes. And this should be there in all the projects, but unfortunately it does not exist in most of them. So again, it's up to the developer how they interpret and how uh, smart they are to ask proper questions so that they don't make mistakes. Otherwise, you build a functionality, it doesn't work that way. You're working in Agile Scrum, you have only 14 days in a sprint. So if this functionality you build about adding a book and you forgot to add a logic about checking if the duplicate book exists or not, then you can just imagine the tester who is going to test this functionality, he or she is going to report an error or bug. And then you have to redo this whole thing again, and you don't have that much time. It's that simple because you will be loaded with other works in that sprint. So which means you will not be able to complete the functionality, and that goes to the next sprint, and it does not give a good opinion about you as a developer in the team. So when you start building feature, make sure you understand the requirement properly. If there is any kind of sequence diagram, class diagram, interaction diagram available, go and check it and only then start building it. So I think we covered all the theory part, and now we need to go and start the development part. Before we do that, Are there any questions so far from anyone? No? Okay. Then let's go and build the functionality. So as we understood that our system will have, we are going to build only one microservice component, this one today. So for that, we are going to use technology as Java, but no one is stopping us to choose .NET, PHP, Python, Node.js, or Golang, or maybe in near future there's another technology. No one is stopping us. But we decided to use Java and one of its framework called Spring and Spring Boot. So as we have decided to use Java and Spring Boot, we need to have certain prerequisite. You must have the Java installed first, and Java as of today is already divided. It's no more open source if you go for Oracle. So there's also open source version of Java which is free. You go with this project called Adoptium or Adopt Java, Adopt JDK. You can use Java 8 also, but best is to use 11. You can use Eclipse or any other tool, but in Eclipse has problem that it hangs a lot. So that's the issue with Eclipse. So I go with IntelliJ, and IntelliJ is much better compared to Eclipse. There's another tool that we will need to test our services, that is Postman. So we are going to, I'm going to show you when you need it. But if you just type Postman download on internet, you get this first link. Go to that link. Based on your operating system, you can download and install this. And this is what we will just build now, start to build now. We will basically have a register author functionality. We will have author can add a book. Author can get all his books. Author can update details of a book. Author can just update the price of the book. Author can delete the book. Author and he can search a book, and we can also see author profile. So this is what we will build. Are you seeing my screen?
Yes, sir.
Okay. So first thing first, you're seeing the GitHub page, right? Where it's showing the notes.txt. Can you confirm which screen you are seeing?
Yeah, we can see the
GitHub page.
All right, thanks. So now the first thing that we have to do is we have to go to Spring Initializer. Just type on internet, because there are multiple ways you can create a Spring Boot application. So Spring Initializer is one of the way. And as I said, these components that you see, the different the components, API gateway, discovery service, and config server, all these are one Spring Boot application only. They are nothing different. And our book author will be also a Spring Boot application. So for all these app components, we have to go here every time. You go here, and first you choose the build type. We are going to use Maven with Java, and then you must choose a stable version of Spring Boot. So you see snapshots. Snapshots are, of course, stable, but the non-snapshots ones, they are called releases. They are much stable. So go for this. And after that, what you can do is you can choose your, you can give your group ID, because as we said, Maven has group ID, artifact ID, name. So you give the name of the group of what you are building. So let's say this will be a group of, my name of the group is let's say my company, and then that should be the group. And what should be the artifact? So what is that we are building in our here? It's just we are building the book author service. That's what we are building. You can give this description, and here you can get rid of this hyphen because this is going to create the package. And here you can choose 11. Of course, you can go with higher version, but prefer 11 because this 17 and 19 they have other modular structure of Java. So go for 11, and you can click here generate. But then if I click on here explore, you will see the POM which will get generated. So this is the POM that we will get generated. So we need to add some dependencies to make sure we are able to build REST APIs. So first one we will go with web. Web is a component or a dependency that is going to help us build RESTful services. So it will give us lots of annotations. So we'll take that. Then we'll go for data JPA. I'll explain what is that. And then we'll go for Lombok. Lombok is a third-party library or a tool that helps us with the utility things like we do not have to create getter and setter functions all the time. We can directly just use some annotation. We don't have to use create getter setters or default constructor or the argument constructors or those two strings, all those methods annotation is already provided. So we can use those annotations. So you see it reduces the boilerplate code. We would also need a database. So I will say H2 database. We will take the H2 database for now, which is the in-memory database, but we will go with the file-based part of it. We'll see that. And so far this much. So I'm going to click here and generate. So it's going to download that book author service for me. So I'm going to click on show in folder, just extract this, and you can keep it to the place where you want. For now, I will leave it here itself. Let's say you can, if you keep it in a location, C drive, D drive, in the code base, whatever structure you follow. So I will extract it here. So this is my component. Now I will take this one. I will open IntelliJ. And in the IntelliJ, I can just go and say open. And I can press this and I can import this component right here in my IntelliJ. It will ask to trust, so just say trust, and it will ask whether this window or new window. So I'll say this window. So it's going to open that for us in this window. And as soon as it will open, you will see it will automatically start downloading the Maven dependencies from our POM file. So let it download that. And if at all it asks you for add a Lombok annotation, this will be a pop-up here somewhere. You can click OK. This we don't need because we already have JDK JPA buddy. We don't need because we'll design our own JPA system. So you can click OK if you get a pop-up about Lombok. So that Lombok annotation gets recognized in IntelliJ. So now this is our one microservice, book author service. So for API gateway, for discovery service, for config server, or let's say order service, you have to repeat the same process again and again for different microservices, and you need to open them in different IntelliJ, and each will be building accordingly with the Maven. We just added the Spring Data JPA. So let's try to understand what Spring Data JPA will do. So here, If we go to let me create a new board. Usually what we do is there are two types of databases. One is called SQL based database, SQL, and another is no SQL. So SQL means structured query language. No SQL means it does not use SQL. So in the structured or the SQL way, how the data stays is it follows RDBMS, relational databases, relational database management system. What does it mean? Relational. The word itself says relational, so which means they have relationship. So if I create an author table here, it will have its own ID. It will have different rows and columns, and there will be a primary key here. Similarly, if I create a new table called book, it will again have columns and rows, and it will have its own primary key, which is book. So now, according to our picture, there has to be a relationship between author and book, right? So this particular relationship we can achieve by saying that do one thing, keep the primary key of the author as another column inside a book. So we will create another column and keep here as a foreign key. Foreign key, the author ID we will take and keep it inside the book as another column as foreign key. So whenever a new book gets created, we know which author to assign that. We will add an ID here, author ID. Let's say there are two author 1, 2. So we will take, let's say author 1, we'll assign this. New book, again author 1. New book, author 2 this time. So book details, when we will add, there will be new entry. So we are seeing that there's a relation, sorry, there's a relationship between the author and the book. And the data that we are storing is in a row and column format, table structure. And the relationship is by primary key, foreign key relationship. So these kind of systems are called structured or SQL based. No SQL based, they don't follow this structure. They don't have tables. They don't have rows and column. They just have data stored in key value pair like JSON. So in the one of the example of NoSQL is MongoDB, where it stores data in the format similar to JSON called BSON. So yeah, so now if we have this NoSQL form of database and SQL form of database, here's our Spring Boot application. We can either use NoSQL database. An example of SQL database is Oracle, Postgres, MySQL. There are many. Or we can use this database. Choice is up to us. Our Spring Boot. So we can decide to have one microservice using NoSQL, another microservice using SQL. No one is stopping us. But here today we are going to use SQL for our book author. So now, how should our Spring Boot application store? How should our Spring Boot application store the data, read the data from these tables, or update the data? Usually, if you see the SQL command to, let's say, store a new entry into the database, so it says insert into values, the DML commands, insert into values and the column name and the values. For update table name, set these columns. Query, if you want to do some query, it's select star from. So these kind of commands runs. But as a Java developer, let's say you don't know these commands, don't know SQL language. So how can you interact with the database? That's where something called Spring Data JPA comes. And Spring Data JPA is built on top of the JPA specification, which says that every table in the database will be represented by a class in Java, and every column in that table will be represented by fields in Java, and the values in each row will be represented as an object of that particular class. So object 1 is will represent row 1 of book. Object 2 will represent row 2 of the book. So this is called ORM. Object, which is this one, relational mapping. So object is getting mapped to a relational table. And who is doing that? The JPA specification. And Spring Data JPA is built on top of JPA specification, because of which it helps us to write query to the databases without knowing these SQL queries, without any knowledge of that. So as a Java developer, you are free to not learn SQL and just use Spring Data JPA provided methods to call and do all the operations in the database. So that is what Spring Data JPA is. It's an ORM tool that helps you communicate to the database without the need of learning SQL. So we covered this aspect also. What does it mean? Now we have to go and develop our application. And our application development will start with, of course, Spring Boot. We will see what it is. We started with local environment setup. Database we will also see. For now, we are using the normal database, H2 database. This we saw what it is. So now we have to develop our application to achieve this functionality. So before we do that, let's take a 8-minute break. Be back by 10:30. Is it okay? Okay, so now we will start with our application development, which is we have the Spring Boot for one of our microservice, which is the book author. So what happens if I just go ahead and start this application? So if you see the whole structure of Spring Boot first, here you have the POM in the root file. In the root folder, you have the pom.xml, which is the Maven POM file where you basically say what is your parent dependency, what is your applications detail, which is here, what we gave in the while generating the from the Spring Boot starter. Those information is available here. We are using Java 11 and the dependencies inside the dependency tag. So these are the dependencies that we added. And there's a plugin which is added by default for compiling or building our application via Maven. So if you want to build your application again, here you will see this is your source folder and this is your main Java resources. In resources, you keep everything that is related to, let's say, properties or configuration, other things. And in the source, you keep the source file, which are your Java files. And in the Java files also, there can be two types, source main Java and then source test Java, which is here. So you will get by default one test file, test here, and this test is uh, there's nothing in this, so it doesn't make sense. So just get rid of this, otherwise your application may fail while starting. When we will learn about writing test with JUnit, then we will explore this area. For now, you can get rid of this. So our focus will be source, main, Java, and source resources, source main resources. In Java, by default, it creates a main method class, which is Spring Boot, and annotates it with Spring Boot annotation, Spring Boot application annotation. And in this main method, it just starts our application. It says Spring Boot application.run and passes our class. That's it. And everything is taken care by Spring Boot. So if I go inside this annotation, we can see this annotation has enable auto configuration, Spring Boot configuration, and component scan. What it means that these three annotations are combined together to form one annotation. So if we quickly see what are the components of it, component scan says whatever we keep inside the package in which this application is file is present. Let's say this file, and this is present inside book author service. So whichever Spring Boot annotated class we will keep in this package, Spring will automatically detect it. And enable auto configuration means if the annotations that we are going to use Spring based, those annotations should be automatically kicking in, and the dependencies that we will add in our POM XML, let's say we have added the database part, this one, this should also automatically kick in. That's what it says. Any configuration that we have should automatically get executed, auto configuration. And Spring Boot configuration, this is just another class for configuration, which means in this class or the class annotated with Spring Boot application, we can have @bean annotation used, @component configuration annotation used. Any kind of Spring Boot related annotation can be used. And this class itself can act as a configuration class. So that annotation is a combination of three other annotation. One for finding all the beans, another for telling that apply all the configurations which are present in the POM XML, which is the class path. And configuration is this class should act as a Spring configuration class, which means we can define all kinds of beans and other things here. So having said that, if I now go and just double click here and right click on this file and run this application, you will see what will happen. So here, as I was saying, if it asks you Lombok, just enable that. So if I start this application, as enable auto configuration is already enabled, in the POM XML, whatever dependencies it will have, it will try to apply that. And we have a Spring Data JPA dependency, which means it will now start looking for database related configuration also on the start. So if we see here what happened just now, if we go and here we see we have added the here it's starting the Tomcat, which is the embedded server inside our Spring Boot. It bootstrapped the Spring JPA repositories. We have not created any repository, so it did not found any. We'll create them. And slowly what it did is it started the ORM framework, which is underlying the Spring Data JPA. It's the Hibernate framework. And then it started our application in H2 database mode, and that too in the in-memory H2 database mode, which means as soon as I stop the application, all our data will be lost. But we don't want that. We want our application to keep storing data even after we stop the application, and when we start, our data should persist. So for that, we first need to go to resources and apply some configuration. So here we have this application.properties file. We can also have application.yml files. YML is another format. It's called yet another markup language to specify Spring configuration. So here we can give any kind of configuration that we want. We will also see how to make it profile based, but for now we will just use here. So if I want to run my application on a separate port, I have a configuration called server.port, and let's say I want to run it on 9000. Now it's starting by default on 8080. That's what we saw. So if I want to override that and want the Spring Boot to start the Tomcat on 9000, then I have to specify it here. So if I start it now from here, you will see now it should start on 9000. So you don't have to remember any of this. You can just Google also server.property or start Spring Boot on a different port. You will get the configuration. Just be careful that you take the right configuration based on the Spring Boot version you are using. So you can go in the POM and see which version of Spring Boot you are using. You are using 2.7.5. So sometimes the properties are different for different kind of Spring Boot version. So now if I go and check the server or property, here you see now it's running on 9000. And if I don't give anything, it will basically run on 8080. But in a microservice architecture, we don't give this port. We basically keep the port as 0 so that the port gets dynamically generated by the service discovery so that it randomly assigns a number and we don't have to worry about the port. But that's a microservice concept. We will not talk about it now. For us, the goal is now to configure our database and entity classes so that we can build our application. So we are going to use the H2 database. So I'm not going to waste much time typing them. I can directly go here in my configuration of an application already existing. And I will explain you what that means. For now, forget about this local test and other things. We will talk about it later. This is our notes. So here we have certain configurations. So let me copy them one by one and then show you what it means. So if I take this and paste it here, it means that first thing is I should be able to access the database itself via my browser. And on what URL I will be able to access? On the same URL in which my Spring Boot will run, because we are using an embedded H2 database. But then I will use localhost 9000 and then this URL /h2-console to access my database. That's what I'm saying here. Enable the access from the browser and this should be the URL. Next is we need to provide the database username, password, and the URL. So this other configuration related to that. Let's say our database name is book author service DB. If I then I should copy that and paste it here. Book author service DB. And then by default, the username of this H2 database is SA and password is nothing. Then we need to tell Spring Data JPA what it should do when it restarts. So we can decide to say Spring Data JPA that every time my application stops and starts, drop all the table in the database and recreate them again, which means that I will also lose all the data that was saved earlier. So this DDL auto property has value update, none, create, those kind of things. So if I put it as create, then it's going to every time restart. So it's going to drop the data in the database and drop all the tables and recreate them again. But if I keep update, then it's going to every time I restart my server, the tables will not be dropped, data will not be lost, and any new changes in my entity will be updated. That's what it means. Then there are two more properties. These two properties, this says that because we know that Spring Data JPA is built on top of SQL or the query. So internally it generates SQL query. Those queries we want to see in our console. So in our local environment or development environment, we can enable this to true, but you should not enable it in production. And there's something called as dialect. Dialect is a class which is very specific to every database. And this is a class which creates Java, whatever query we will write in Java, this dialect class will translate that query into specific database understandable SQL queries, which means this dialect will change for MySQL DB because then MySQL has a different syntax of writing the query. So the same Java class query will be converted in a different way for H2 database and different way for MySQL database. So I think all this is clear. So if I start my application now, my application will start and we can access our database via particular URL. So here it's starting up now and it says H2 will be available. H2 console will be available on this particular URL and the database that will be available at this. So let's go and try to access it. So we'll say http colon localhost instead of 8080 we need to go for 9000 because that's the port we have chosen, and then it says the database will be available in H2 console because that's what we said. So we'll copy this path, hit enter. So this is HTTPS it took. There was a space. Hold on. So this is our database which is available. Database is running. And because we are able to access it on the browser is the reason is we enabled it to true. And now our database path is this one. So copy everything, jdbc colon h2 file. You go ahead and paste it here. The username will be SA, password will be nothing. So you can test the connection and then you can log in into the database. So now this is our database. It has no tables, nothing. So we have successfully connected our Spring Boot application to our database, H2 database. All right. Now, the next step is the core part. What are our actors in the application? So we saw there are mainly two actors. Of course, you can keep extending this application. No one is stopping you. So I will close this. But for now, there are two actors majorly, author and book. So we need to go and start creating package to store them. So as we learned that we need to have layered architecture, right? This layered architecture. So this layer, each layer will become a package and the DTO will be stored also in the package and the entity classes will be also stored in package, different package. So for now, we are only going to focus on creating entities. So we'll add them in the package. So right click on the package, click create new and then package. And here we will just say entity. I will hit enter. So the first entity that I would like to have, it will be a Java class and I will say it's book entity. And it will not be in anything else but then a Java class. Now it is an entity, but if you see it's just a Java class. It's inside a package and it's a public class. That's it. How does it become an entity? So we apply an annotation called @entity. And this annotation comes from javax.persistence. Then we want to give this entity a name when the table gets created. So we say @table. And here we say the name of the table should be, let's say, book underscore table. This should be the name. Then we are going to create some fields. So first thing we will create private long, the primary the primary key, which we will call as ID. Then we will have a book title that will be a string. Then we will have a book description. Again, that will be a string. Then we will have price of the book, which will be a double. And we can continue to have as many fields as we want, but let's keep one more as genre. Now, in traditional way, I should go ahead and, because these are private fields, it cannot be accessed outside this Java class. So we need to access them outside, right? So in traditional way, I could say right click, generate getters and setters. Same way, if I need constructor, I can click constructor and choose what kind of constructor, one argument, two argument, no argument. But all this boilerplate code we don't need. We can keep things simple. And we can take help of something called as annotations provided by Lombok. So if I need a getter created for all the fields, I would say @getter. If I also need setters functions, I would say setters. If I need a no argument constructor, I would say no arg constructor. It's that simple. Then it will automatically create those for us. We don't have to worry. Then every primary key column should be annotated with @ID because we know the nature of primary key in MySQL is that it should have unique and not null values. So those constraints will be added by this @ID. We can also, we want the value of the primary key to be generated automatically. We will not generate the value for it. So we will say generate the value automatically, and then what should be the strategy that you should use while generating that value. So we said use automatic, which means whichever strategy for generating this value for this primary key is supported by this database. In this case, it's S2 database. Use that strategy automatically. So now we don't have to worry about these values ourselves. Of course, there are other things also. On top of every column, every field, we can add a column annotation, and we can say name equal to, I don't want to show it as title. I want to show it as book underscore title. So I can give this one. So in the database, it will create a column like this, and I don't want this to be empty. So I will say nullable false. So these kind of restrictions also I can add. But if you don't give this, by default, it will take this as the database column. Having done this much, if I now restart my application, you will see what will happen in the database. So it's starting the database now. It's starting the application, which means embedded database will also start. And you see something has happened just now. It created a table because we said in our application properties that also show me the SQL query that you will generate. So here it says create table, table name. It took book table. Why? Because we said it to take it here in this annotation, book table. And then it created the regular create table query in SQL, but we did not have to worry about it. We just wrote Java code. All those were taken care by Spring Data JPA. So it created all these queries for, and then it also said which is the primary key because we added this on the ID. And it also generated a sequence in the database in Java or sorry in MySQL or any other database. To generate automatic in values, we use something called a sequence. So it started a sequence starting from 1 with increment by 1. So every time now it did that because of this annotation. So every time the value of this will be automatically generated for us. We will not have to create it, and it will be generated by the gap of 1. So this is what has happened here. Let's check now the database itself, what happened there. If I refresh, I will be logged out. Then I click on connect again. You see it created a table, book table. If I run that, just click on it. You can clear, just click on it, run. There's no data here. But you see, it created all the columns. If I click on plus, I can see the different columns and their data types. If there are any restrictions, I can see. Here it says there's an index attached to the ID column. And it is true. We have given that index, and that is here on the primary key. And each column will have its own data type. Here it's character varying, but this data type is different. Now it is specific to H2. Maybe MySQL is using a different data type. So those things also we don't have to worry. And now this book title is now represented by book underscore title. Other things are having default name as the field name. Just this one is special because we added it. Similarly, if you wanted to have as a specific size, we could say length. Default, it's taking 255. So if I know that my column, the title column data value with that we will store is only going to be 50 characters, I can give 50. Let's restart it. Because we have added the update property here, it's not going to drop the table, rather it's going to update the existing table. So now the book is here is 255. It should change to 50. Let's see. Still taking 255. Strange. This should have been already reflected. Did it not generate any query? No, it did not generate a query. I was expecting an alter query here being generated. Because we are modifying the structure of the table, so it should have generated an alter query. Let's quickly apply this on here and see if it's generating that or not. At that column, and then we will just say length of the column. This genre will be also very small, right? So we can say 50 here and save it, restart. It's a job of Spring Data JPA to pick up these changes and apply it on our table. It did not generate the alter query. So you can also look for if something, let's say it's not working as expected, because it should work according to the update thing. If it's not working, you can also look for on Google why it's not working as it should. So we can quickly check what happened. So it has different values. It says create, drop, validate, update. So it says it should modify the schemas at the startup. But it's not doing that. So that is very strange with this database. Let's check here. Create, it says Hibernate first drops all the table and creates new tables. Update, the object model created based on mapping XML with the existing method, and then Hibernate updates the schema. It should have done that. It never deletes the existing tables or column, even if no more required by application. Yeah. So here somehow it is not working for H2. We will try to verify this when we will change the database to MySQL. For now, if I change this to, let's say, another DB, then it will automatically reflect that. So let me change it here. You will see it will create another DB, but it is not the same DB. So if I stop and restart it, so here, while having a new DB, it does take 50 as length and it generates the query. Also, the book title is 50, but with the existing, it is not updating. That is something, maybe a bug with H2 database dialect. So if we go here also now in our database, we can check that. So the length is now 50. Anyways, it's okay for now. It's not a big concern. So now we saw if we are creating one entity, it gets table gets created. So similarly, we need to create another entity in our table, in our database. That will be for author. So if I can go to now, I can directly create new class author entity. And here I can, for simplicity, I will just copy these annotations. They're not going to change. Put them here. And here we can say this will be author table. An author table will again have primary key. So let's give it a name. We can have the same name. There's no problem with that. Author will have a name itself, the author name. So private string name of the author. I can press Control D to duplicate this. Email, phone. And if I start this, you will see another table will of course gets created. But then there's no relationship now between the book and the author. That is what we have to establish now. So it's starting up. Yes, it started that and it also created the table. If I go, okay, we are using one only, DB1. So if I connect here, we see that here we have the author table created and there's a sequence created for this as well. And these are the columns in it. But what about the column about author? So we said the relationship between the author and the book will be something like one author has multiple books or one author has written multiple books. So there's the author Just today he wrote one book, book 1. Tomorrow he wrote another book, book 2, another. So what we are seeing, book 3. So if we want to keep, so this is our author table. And here we have the author ID. Author ID, this is author table. So we have author 1, author 2, maybe new author getting added every day. Author 3. And this is our book table. And here we have the book ID again. Book name, book whatever, and then also this. Here also author name and author phone, email, whatever column we want to have. Now let's say I am adding a new author. So I can just say author name is this, email is this, phone number is this. Again, new author, author name, email, phone number. But what if I am adding a new book? I will say, of course, the ID gets automatically generated. So it's 1 or 111 or 1, whatever, 222 here. And the book name, book genre, book title, book price. And then we need to assign one of this author to a particular book. So here, what should I write? If I write 3, then this book belongs to this author. So here I have to add a column author ID as the foreign key. So that from this column, this value gets assigned to this. What about if I add another book for the same author? I will repeat that value. What if I add another book, but this time it belongs to author 1? So I will add another value here, 1 here. So if I search for get all authors for book number get all books for author ID with 3, then I will get these 2 rows, these 2 books. So now we have to establish relationship. So we can clearly see that we cannot keep the book ID as a foreign key inside author, because if we keep that, we cannot repeat the books. But we can, it is wise to keep the author ID inside book table so that when we repeat the book row, the author values can be repeated. So here we can say one author has many books. So in the author, we will have a relationship, one author has many books. But in the book, we will have many books belongs to one author. So many books belongs to one author, and here one author has many books. One author has many books. Many book belongs to one author. So this should be our right relationship that we can establish in these 2 entities. So now here I will go and I will say private. I have to keep more than one book as a part of this author. So I will make it as list of book entity, and I will say books import java.util. And as we said in author, we say one author has many books. So here we will say one to many. Same way, if we want to do a bidirectional relationship, we have to go to book entity, and here we should say private author. So now we will say many books. Many books belong to one author. So we'll say many books belong to one author. Done. That's it. What will happen if I just restart this? Unfortunately, it will create a third table also, because we have not said in any entity, we have not said who should be keeping the primary key of one in another as a foreign key. We never said that. So what by default JPA will do is it's going to create another table with its own primary key ID, and it will keep the primary key of this table as one column and primary key of this column table as another column. That's what JPA will do silently. So there will be a third table created, but we don't need a third table. But if we don't say, it will by default create it. So if we go now and check, we'll see now. Let's go to the database. Refresh it. Now we have only two tables, author and book. See, it created a third table, an author table books. And here it kept the author ID and book ID. Both the tables, this table's foreign primary key as foreign key, and this table's primary key as foreign key. So three tables got created, but we did not need this three table. So let me drop this third table and show you. Drop table. Click here, run it. And now I will do another change, and you will see third table will not be created. And that change is we need to say one table, one entity, that other entity inside other entity, the ID foreign key will be kept. So in here in the book entity, what I will do is I will say mapped by, and here I will just say this books, inside this books you should map this. So here if I write apple apple, then I should take this apple and add it here. Where it should map, we are saying. But if this was author, so I should use this author inside this as a mapping. If I do this a small change in one-to-many, I just say that mapped by author this books, then you will see it will not create a third table. Instead, it will basically add another column in book entity for author ID. We'll see that now. So this is this is how the JPA works internally. So server started. If I refresh now, you will see there won't be third table. The two table, but now there will be a new thing. Inside book table, there's an author underscore ID automatically created as a foreign key, which means our purpose is solved. In the book, we got the author ID. That's it. So now we have created the relationship between entities successfully, and our entity tables are created. So let me stop the server. So now what we do, we need to also have DTO layer. So I will say book DTO, data transfer object. But then we need to store them in DTO package. So right click new package as DTO. I'll move this class there. And we also need an author DTO. We can keep the exact same fields here, no worries what we have in the entity. Because it is a small application, we will not see a difference, but in a bigger application, we will definitely see difference. Why we need a DTO? We can use the same entity also on the, we can use the entity itself here on this controller layer, but then our application will not be loosely coupled. It will violate different design patterns. The loose coupling will be lost, which means if anything changes in my entity, then this layer also has to be modified, the code, and also the database layer also has to be modified. That's not wise. Always we build big application with considering some design patterns in mind, and loose coupling is one of the very important ones. So having a separate class will help us achieve that for now. So I will go and paste it inside author DTO. We don't need this mapped by because here it's not going to act like that. And here it will be book DTO, list of book DTO. And in the book DTO, we will, of course, here we need to add other annotations at the rate getter from Lombok, at the rate setter. And if you want, we can have no argument constructor. We should add also two more annotations. As remember, we said that our Java classes should be automatically converting to JSON and JSON to Java. That will be taken care by Spring Boot. But then what if we want to skip some fields from the front end? If we are not getting the fields like name and email, but still our other fields, then sorry, if we are not getting name and email, other fields like phone number or books should be automatically populated. Same way, if books is null, in the response, we don't want to see this data. We just want to see this data. So how do we enforce those kind of things? There's two more annotations which we should use. I will quickly take it from here. And this I will explain what they mean. So here we say, first import it. Here we say JSON include non-null. Only non-null values field should be populated. And JSON ignore properties, ignore unknown true. If at all some fields are coming which is not in this Java class, those values should be ignored. Instead of throwing error 500 or 400 bad request, those values should be ignored. All right. So same thing we need to now do for the book. So I will get rid of this. This we don't need. This we don't need. So if I take this and copy it and put it here in the book DTO. And we'll take the same entity fields here as well. We don't need the database related things here. Okay, so now our DTO layer is also ready. So now the DTO classes will act here in the controller and service. Entity will act here. So now let's go ahead and create our first controller. So here I'm going to create another package for controller layer. So I will say controller, and I'm going to create a controller for all the operations related to book. So I will say book controller. Similarly, I will create a controller class for author. So here, now what we will do, this is just another Java class. So remember, I said REST API means you are able to map a URL to a Java class method, and every method will have a unique URL. So how do we do that? So first, make your class annotated with @REST controller. Only then Spring will be able to map a URL to your Java class. And then what I'm going to do, I'm going to just create here public string. For now, I will just say string. I will create a hello method. And from here, I will just say return hello. Now my job is done. I created a class and created a method, but I've never linked this method to a URL. So how can I even access it from the browser? I cannot access it from the internet. It's not a RESTful web service. I need to make this as a RESTful web service. And how do we do that? Using Spring provided annotations, which are equivalent to HTTP methods. So let's say I want to access this method via get call. So I will say @get mapping, and I want to access it under, let's say, I will create a method, API or a URL I will decide. So I will say greet/hello. So whenever somebody hits greet/hello, they will be responded with hello REST API, this method, let's say. So who decided on which URL my web service will be available on internet? It's for now I decided, but in companies, when you're working in project, there's already a YML file, which can be in the Swagger documentation or open API configuration, that will be provided to you. And that configuration will act as a contract between your consumer and you, which means your consumer will see that YML file or contract, and they will say, okay, whenever we will hit /greet/hello, this will be the output. In following the same contract, you will also develop the functionality. What will happen if any of you, either the client or you as a backend developer or who is developing this microservice, deviates from following that particular contract? Then of course you will have problem. They will be hitting something else in the URL and you will be developing something else. So their request will never reach to your server via internet. So if you can go to Swagger editor, I can show you an example of how the document looks. So let's say this is a pet store application. So this is how, this is the contract between the front, the backend team who is developing the API and the consumers of the API. The consumers of the API will be provided this file, this YML file. This can be also changed to JSON format. So they will see, okay, there's a path which is /pet, and that's a put method. And what it does is this. In the request, it takes this. And in the response, we get a 200 OK with the data, which is pet schema. Similarly, there will be other endpoint, pet/find by status. It's a GET request. All this will be mentioned here in this document. This is a very important document. It's also called as Open API specification or Swagger specification. It's a contract between the consumer and the provider of the service to build the same thing. Otherwise, you both will be, so if the backend service is not ready, a web service or API is not ready, the front end team can at least create dummy data and they can complete the front end. And once the API is available, they will just change the base URL and then it should work fine. So this is how it looks. There's a pet /pet, which is put, update one, post, creating a new pet, find, delete. So this Swagger documentation is going to, or the Open API specification is a contract between the parties who are producing the API and who are consuming the API. Is this available elsewhere? Yes, it is available whole throughout the network. So if you go to your government website, data.gov.in, or you go to COVID related data, you can find those. So if I go to APIs here, every country's government provide the data. So let's say this is a COVID vaccination data. If I click on this, you see they have provided us a Swagger documentation which says this is the URL which you have to access. You have to send a GET request. You have to pass an API key and format. You can also filter the data and you will get response something like this. So in the example values, you can have XML because here the response type is XML. You can also have request. So here I did not provide any information, so it gave me bad request. But there are more and more APIs which you can hit on internet. So the API provider or the web service provider is going to provide you that contract, which will look like this. Based on that, you have to build your front end, and the API provider is building their back end. And every URL is mapped to a method. How is that possible? We'll see that now. Let's say I will start my application. If I go to localhost 9000/greet/hello, this method of this Java class is getting called. Same way, I can create more Java classes. I can have one or more methods in them, do whatever logic I want, and I can give them a URL and I can talk to them via internet. That is the power of REST API. So if I go to localhost 9000 and hit this service, if I make a slight mistake also, it will not work. See, I did double slash. If I get rid of this, you see it worked. Because each URL, this URL is mapped. This URL means a Java function. Here it's a Java function. It can be a Python function, PHP function, .NET function, Node.js function. But here I was just making call query. So I did a get. Can I send data with this query? Yes, I can. So let's say I want to send data like this in the path. I will say name. And then what I will do, I will, instead of hello, with that, I will just say, here I have to accept that field also. So I will say that path variable string, and then I should use exactly this field name here. And now if I put the name here, now my service will be behaving very nicely. So now it will be whatever I will pass here. I will say pass John, so it will print John. So this is one way to pass the data from the browser to my service. But with post, I can post or put, I can pass more complex data. I can pass the complete object in my request. So if I go here, now if I hit this, it will give me error because there is no such API. But if I say here, let's say magic, it says hello magic. If I say Spring Boot, it will say hello Spring Boot. So now what happened? My application became dynamic. Now from internet or via browser, this can be browser, another Spring Boot or a mobile app. Anyone can call this API and they can talk to my Java class, this method. And here I'm just doing a plain simple logic of returning a string. But from here I can make it a database call. I can make another API call in my microservice architecture and then do whatever I want and then respond back. So that is the power. So this is what is REST API. So that's why I was saying RESTful web service is mapping of URL to a Java function. So now let's say we want to have a functionality of creating an author. So let's do that. We'll create an author. So I will say public. For now, we don't know what will be the return types. We'll say void register. We'll register the author. And while registering the author, we know the author, it will take the author DTO as the object. So we'll say author DTO. That's what we will pass. And now we want to basically say this will be an object which we will pass. So let's add it as a post mapping. And before every call that happens, I want to append certain other URL thing in that. So I will say request mapping. I will say slash API slash v1. So now because I added this, so this URL will now change. We need to append always now this also in front of it. This will be the new URL to access this. Why do we add this? Because each API has a version. Tomorrow, if the version changes, you can create another author controller V2 version register one. So we should always maintain version. So now in the post mapping, I'm going to say for registering an author, use slash authors, you use always plural and you say register. So whenever somebody is using this URL and the URL should be like this, then this method will be called. Whenever somebody is hitting authors slash register. Then this with a post mapping, then this method should be called. And let's say for now, I will just say system.out.println here. Author dot get email. For now, I will just print it. I will do nothing. So let me start my server in the debug mode. I will start my server in the debug mode and I will put a debugger here. So this is how you can also debug your application. So my application is starting. So let's wait. It says started. So let's go to now from the browser. We cannot hit a post mapping. Post annotations, post request of HTTP can be only hit from tools like Postman, REST client, Insomnia, other things. So we have Postman. So you can also download Postman. So I have Postman with me. And in this Postman, I can now make calls to my service using different methods. Here I have get, post, put, delete, patch, all the methods available. So now it's about basically register. So let's compare what is our API. So it will be API slash v1. But before that, the port should be changed to 9000. So 9000. So, and then API slash v1 is what we have. Okay. API slash v1. And then we have authors slash register. authors / register. And if it was, let's say, deployed on Azure Cloud, Heroku Cloud, or on your company domain, this will change to your company website domain, like www.obifyconsulting.com. And in the body, we need to here change the format to JSON. We need to send JSON. So what I'm saying, email and password, key value pair. This is how JSON looks. We want to send key value pair. Can I use any variable name? No. Here it's written E small m small AIL, email. So I have to use exactly email as the key in double quotes. And then the data is string. So I will pass this string value, comma, password. It's not there. So it will ignore that field because we have added this. But there should be a password. Otherwise, how can the author log in? So let's add that. Private string password. Okay. The same thing should be also added to our entity. Otherwise, we will not be able to save the password. Here there is no password. So let's add the password field. So now the password is also there. So now we are going to start our service, but let's also change our database here because we modified it. So here I will go to DB2 so that everything will be starting from scratch. DB2. So if we start our application, the application is starting up. Yes, it has started. Now if we go and if I hit this service, wait, we did not started it in the debug mode. Let me debug it for you. If I put it in a debug mode, then the application, we can see the data itself, what is coming from the client. So now from the Postman, this Postman can be any other application or any front end, anything. But for now, we don't have a front end or a mobile app to test. So we are using Postman. If I click here, now our debug point will stop here. And here is our debugger. And if I now hover here on this field, here it says null, null. But we are passing email and password from here. Other fields are not passing, so it should be null. But why is the two fields null? There's a reason there for that. Cancel this request. Because we did not tell Spring to convert that JSON JavaScript object notation into Java class variables. So how can we say that? There's an annotation called @request body. Now Spring will convert this JSON format into Java class variables and set the value automatically. What about the response? If we want to respond it back, let's say I want to respond back the same data back here. I will say return whatever is coming to us. I will just return it back. But this is Java class. Spring should automatically convert this to JSON. Otherwise, the browser will not be able to see Java class. So here there was used to be an annotation called @response body. But we don't have to put this annotation anymore because this REST controller is a combination of two annotation. One is REST controller and one is controller and response body. And the response body is going to take care of conversion of our response Java class into the JSON format. So now if we restart, this should have value and the same value get responded. Let's debug. We'll clear up all the console. And now if I hit request, it stops here. If I now see the data, email and password has values, others don't because we have not passed it from the front end. And now we will return that data. So it will get returned. So I will resume it. You will see at the bottom, here is the response. So this was our request and the response is exactly same because what we are passing is what we are responding. But the response is also in JSON because the response body automatically kick in and converted it. Here is what you can see the status. If we don't pass any status from our code, by default it takes 200, okay. But registering something is like saving into the database, and that cannot be 200, okay. That should be 201 as per the standards of REST templates, REST contracts. So now let's go ahead and build on top of it further functionality. So we are now getting the data. We need to now save that data in our database because in our database we have nothing. Database is empty. We move to database 2. So if I connect, our database does not have author. But we want this author which we are passing from client to be saved in the DB. For that, we need to develop functionality. So first, which layer is going to do that? Taking the data and saving into the database. As per our layered architecture model, the books repositories should do that. So let's create another package. New package repository. And here we are going to create a repository interface. Remember, Spring Data JPA interfaces are, the repository classes are always interface. So we'll say book repository. I will use this. By default, there will be nothing in it. But then this interface we will extend from JPA repository. And this JPA repository is coming from this. Now, what do we have to do? First, it takes two parameters. First parameter will be the annotation on which this repository will work. So here we have the book. So the first parameter will be book entity annotation. Second parameter should be the data type of the primary key column. So our primary key column is this, whose name is ID. As we have annotated with ID, so this is the primary key column. So what is the data type? Long. So the second parameter is going to be long. That's the data type of the primary key column. Save it. Done. Now we learned that. So we are creating a book repository. Similarly, we have to create author repository. Author repository. And again, it should be an interface. It should extend from JPA repository. But this time, it will be on author entity. So first parameter will be author entity. And the second argument will be again the data type of the primary key column. Again, it's long. So we'll pass long. Okay, now, as per our picture, layered architecture, we have created repository, we have created controller, but we cannot add repository directly to controller. Instead, we should have another layer called service layer or business logic layer. So let's create that. So we will go and create another package called service, or we can also name it as business. Hit enter. Here we have to create an interface, author service, and then we also have to create class, the implementing class. So first here it will be void register. We will register the author, and while registering, what is that we expect? Author DTO. Author DTO. And what I want is after successful registration, we will return the newly created author ID. So I will change the return type to long because author ID is of type long. So for now, I will have only one method in author. Later on, we can add multiple methods. And now I will create an implementing class. And that we will name it as author service IMPL. Author service IMPL. And this will be a class. And this will implement the author service interface. If I hover on it, it will ask me to implement the unimplemented method because that is the nature of Java interface. So now we have created this, but now I need to call the service from my controller. So I can add a variable of book service in my controller and call the method register author. But the problem is somebody should give memory to my service. Otherwise, I will get a null pointer here. So for that, we need to take help of Spring Boot or Spring Singleton design pattern. So I will use @service annotation here. I could have used @component, @repository, @configuration. Everything will create a singleton bean for me for this class. Singleton bean means singleton class. Singleton class means object gets created only once, and every time there is a call made, new object of this class will not be created. Instead, the same object will be reused. There's also another instance called prototype, the pattern, which is used for these ones. We did not annotated this with any @service or @repository because we don't want a single instance of this book to be created. Instead, for every new book, we need a new object. Otherwise, in our database, we will have the exact same books again and again and again if we make it singleton. So it's very important that these DTO classes and entity classes should be prototype, which means every request should create a new object. But these layers, which is book, controller, service, converter, repository, they should be singleton classes. And how can we make a class singleton? With the help of @component, @service, @repository, @configuration. But because this is a service layer, so it makes sense to make it as @service. So now that we have added it as a @service, Spring is going to give this an object. But then we need to call it from controller. So let's go to author controller and let's inject the author service here. So instead of calling the author service implementation class here, we will instead call the author service interface. This is dynamic polymorphism in Java, which means in future, if there's a new implementation of author service, we don't have to change the code. So now here we need to make sure we do an auto wired. Why? Because the memory that will be given to author service IMPL by Spring using this annotation, that memory should be also made available in this particular class. This class there are different methods and functions. So this is another variable. So this variable should have memory. So Spring will create a singleton bean for author service IMPL and take that bean and inject it in all the classes where it said auto wired. So here it will make it available. Now that this is available, what we will do is we can call directly author service dot register and pass the author DTO. Done. We pass the author DTO from our controller to the service, but in the service, now we should have the similar pattern as described in our picture. So in the service, we should have the repository being called and pass the data. But from service to repository, it is entity. So we need to also do a conversion. So we will use the latest technique of conversion instead of this writing a method. So let's see, see that. So first I will say, I will inject author repository. Author repository. And then I will auto wire it, otherwise it will not inject the singleton bean. And here, what I will do is, if I do author service, if I simply just call here author service, author repository, sorry, dot save method, I can already see it's taking an entity class, but what we have a DTO class. So here's a mismatch. If I pass a DTO here, it will not take. It will say you're trying to pass an DTO to an entity. So we need to do a type conversion. We can do that very easily by calling a Spring based utility class. So what I will do, I will say author entity equal to new author entity, and I will call bean utils dot copy properties, and it will tell me from where to where, from source to target. In this case, my source is order DTO. This is holding my data, which is coming from Postman, the client. I need to convert it into entity. So if we have passed only email and password, that will get converted automatically. And now this, after execution of this line, this entity will have the data being passed, which means it will take from author DTO email, it will take the email and pass it to the author entity email. Same it will do for password. And if there are more fields, it will do that. And now I can call and save. After saving this, what it does is it returns the saved object. And as we said, to create, as we said, it to create in the entity, we said to create the primary key value automatically, which means if the data has been successfully saved, this should return us an ID value. The value of this ID will be available. So for now, I will return that dot get ID. Perfect. So now from our controller, we are calling the service, and from the service, we are calling the repository. Repository is saving it for us, and we are returning it back. But I want to change one more thing. In the author controller, I just don't want to return the data. I also want to return the status code as 201, which we should always do as a best practice. So what we will do here, what I will do is I will create something called as response entity. So whenever we want to send data and status code together, we should use response entity. So I will say long. Long is the data type which I want to send. So response entity, go to response entity, new of response entity. Here I will pass the data which I want to send. So here from the service, we are returning the long author ID which got created. Author ID that got created, we are returning. So I will pass that. That's why I said long. That's my data. And then the second parameter, I have to pass it as HTTP status. And this time the status should be created, which is 201. And then from here, I will return the response entity, which means I have to now change it to response entity. So what it means is now we are able to return two things from this method. One is the data itself, which is this, and also the code, status code, which will be 201. So if I start my application again and try to hit this service, we will see a new author being created in the database and the author ID will be returned. So if we go to the database now, connect author table does not have any data. Application started. Let's register a new author. See one, which is the author ID, got returned and the status 201. Let's check in our database. Run it again and you see we sent only email and password. So it's here and the ID generated automatically and that got returned. And that is what we received. And here is the query for adding author or into our table. So now that we are able to create an author, we can go and create more functionalities like author is able to add a book, update a book, delete a book, all those functionalities we can create. So let's go ahead and do that. So now we will go to the book service, which we haven't created. Let's create them. So book service, which will be an interface. So what are the different methods it will have? First, it will have a method that will help to add the book. So after successful adding the book, it should return a book ID. So add book, then we'll say book DTO. It will take book DTO to create a book. Then we will also update the book. So after updating, I want to return the updated book back. So I will say book DTO, update book. But for updating the book, I need the book ID. So I will pass a variable called book ID. And I also need, as I'm updating all the fields of the book, so I also need to pass the new book object, which will have the updated values from Postman. Then I just want to update the book price. Single thing I have to update. So I will say again return that book that will get updated. I will say update. This is for partial update. Update book price. And here again, as this is a book price, so first I need to pass the book ID that should be updated, and I also want the price, the new price. So I will say double new price of book. Then what I also want to get the list of books. So I will say list of book DTO which is present. That's over. So get all books, but for whom? For an author. For this particular author, we should get all books. So then we have to pass the author ID. So it's going to give us all the books for the author, particular author. Then we also have to delete the book. So I will say void delete book. I don't want to return anything. A book is deleted when it's deleted. And how do I delete a book? So I say long book ID. I should pass the book ID as the value and it will delete it. So we can add book. Similarly, we can also search a book. So we can search a book. So I will copy this. I will control D. It will return list of book, but this time search. So how do I want to search the book? I can search the book from multiple ways. So I want to search it based on the book title. So I will say search by book title, but I can also make it dynamic. I can say search by anything. But for now, let's say it's on search the book by book title. So now I will create a data type as string that says search. What do you want to search? The search text itself we will take. So these are the methods inside book we have to implement as a service. So now we will create a book service IMPL. So we'll say class book service IMPL implementation. And then again, we have to make it as @service so that it gets memory. And this time we will say implements book service. As soon as we do this, it's going to ask us to implement all the unimplemented methods. So I will say okay. Now to add the book, we need to have the repository. So we have the book repository. So let's inject that. So private book repository. From service, we call the repository. So private book repository, control space, hit enter. Let's auto wire it, otherwise we'll get a null pointer. So that the singleton bin should be of book repository should be injected in book service IMPL. And here we'll do same thing like we just did for author. We converted the DTO to the like this. We converted the DTO to, but then now the source and target will change. So this will be book entity, in the name also, book entity, bin utils, source will be, of course, DTO, book DTO, which is coming from here. And then we will say book repository, and it will say book entity. And here we will catch that updated book entity or the newly one added one and return its ID. So we'll add the book successfully after this. But let's verify that if it is doing that. So we have not created anything in our controller. So let's go ahead and add that. So I will say at the rate REST controller. We want to give a root level mapping also. Request mapping, and this time again we'll say it's API/v1, and here we will say the logic to add the book, and again we'll go and copy this post mapping from the author and modify it according to us. So here we'll say books for a particular book. We want to basically save for a particular author. So we'll have to say authors slash author ID. For a particular author ID, we want to add book. So always we write in plural. So I have written books. So this will go away. So this will be our URL. And here we can say add book. Now we will pass the book DTO here. And here it will return this. Now we need to add the inject the service, book service. So I will say private book service. At that auto add. Then we can call the book service from here and say book service dot book service dot add book. But there is one problem. While adding the book, we need to know for which author we are adding. Otherwise, how we will know for which author's book is which one? So here we are passing the author ID. That is fine. So we'll grab it from the URL like this. We use annotation called at the path variable, and we say long, and we use the exact same variable which is here, author ID, comma. If you want to use a different name here, then you have to use it like this at the rate name. Here you will say ABC. Sorry. Here it should be author ID, and this can be ABC then. Then it will be not worrying about whether this should be same as this, but this should be definitely same as this. But then we will keep simplicity at every level. So here we will say author ID and comma the request body. Perfect. Now our book author our book author here, book service needs to be having also the author ID. So let's pass that long author ID. Again, all this, why you have to pass this? This is all part of the design that you will do, system design. So now, because we passed that here in the book, we should also in the implementation pass long author ID. We pass the author ID. Perfect. Here, now in our service, the first field will pass as author ID, and second one is book DTO. Yeah, here is a duplicate one. So no worries. This should be book ID that will be written. Book ID will be returned. So this book ID, we will wrap it in the data and send it, and this status will remain as is. So that is okay. We will get a author ID and the book DTO from the postman. It's fine. And that we will pass to the service, and it will come to service. And now in the service, We are just saving the book. We are not doing anything with the author, which means we will not come to know who is the author for which book. So first thing first, we should do something like this. We should first find out the author of which belongs to, with this ID. Who is the author with this ID? And that one we can do with the help of author repository. So I will say author repository. We have to inject author repository to do any query on the author table. And as we know, the author repository has the data for author. So we have to inject that. So I would say author dot find by. Find by what? Find by author ID. Author ID is our primary key. So I will just use ID. So ID in the author table is the primary key. So now I will pass this author ID here. It's going to return me something. Let's see what it is. It's returning optional. In Java 8, there's an optional class added that helps us to do proper null checking. So it's going to return optional of author entity. That's fine. So we'll take that optional author entity. I will call that variable. And now I will say if optional author entity dot is present, which means if the author is found, if there's an author found with this matching author ID, only then do this operation. Only then do this operation. That's what we are saying. So now I'm going to take that and put it here. Otherwise, we'll return for now null. So here we found the author, let's say. But where did we save the author? We did not save the author. So in the inside the book entity, we need to, after this conversion happens from book DTO to book entity, right after that, and before saving into the database, we need to save the author that we have found in the database inside this optional class. We have to save that author in that entity. Then Spring Data JPA will take care. See, it is returning an entity. Then Spring Data JPA will automatically create a relationship and the corresponding book will be assigned to a corresponding author only. So let's debug it to, to make things simple. I'll put a debugger here. The application is starting. If there will be a problem, then you will get an error. You need to check that error in this console. Now there is no problem. So I will add a debug point here. In fact, here also. Let's go ahead and create a book. So this is add books, but the URL should be 9001. Sorry, 9000. And we need the author that we have in the database. So let's refresh. Let's check what is the author ID that we have in the database. So I will create run. So author ID we have is 1. So in our URL now, which will form, we'll say API/v1, API slash, we have a slash here for v1. Then authors with an author ID and books. So authors and author ID is 1 because that is what in the DB with books. And let's say I will assign this book. Test title 1. If I hit this, so automatically this author ID should be in this. So the value automatically came 1. And the book data will be in this. So if I over, see test title, all this is there. Of course, ID will not be there because ID will get generated from the database. That's what we have said. So let's go inside this. So if I click on step into, it will go inside this service. So from the controller, we jumped into service and we passed the same data. See, same data that we passed. The first thing that we want to do is from the author repository, we want to check if there's an author with the author ID 1 existing or not. We already saw in the database that an author with an author ID 1 exists. So it will return this author data. So we'll do next. And as this author exists, is present will be true. So it will enter here, it will create this. And now this DTO data will be copied to entity. If I hover now, the entity will have nothing. But right after this line, everything will be copied. Now if I hover on the entity, title, description, everything will be copied. ID is not created because it's not saved, and author will be also null because we have not passed author. So from where is the author coming? Author is coming from here. So now we will do a set of author. After this line, we will see the author will be also populated. Let's check the entity. See, author is also now populated. From where did we got this? From the database. But ID is still not there. Why? Because it's not yet saved. Once this line is done, it will save that and a new entity will be returned with an ID. So let's go to next. Let's over. See, an ID got generated 2. And that is what we will respond. Response, yes. And that is the ID we will get here 2. And this is the ID which we will pass in the response entity, and the we will also pass the status. So if I resume now, you will see response as 2, which is the book ID, and the status as 201. But magically now in our book table, if I clear this and go to the book table now and run it, you will see a book entry has been made. The book title, description, all this value is coming from here. ID got automatically generated for book, but the author ID, which was the foreign key here, got saved because we did this logic. We found the author, we fetched the author. Here we made a query. We got the author from the database. We checked if it was there. We took the same author and saved it in the book entity, and JPA made sure that it relates the ID properly. Done. So this is how we can save multiple books. So the same author can have more books. So if I do this 2, and maybe this also I change to 2.99. So new book will be saved. Send. I will just click on this as resume. So if we go now and see in the database, run 2 books. Same way I can say. So now there are 2 books for one author. Let's create another author itself. So I say Jane. Let's create a new author. Resume. ID got 4. So let's check the ID. Yes, a Jane with 4 ID got created. So let's create new books for Jane. So we will pass 4 as the ID. If you keep passing 1, then it will create it to author 1. So I will say 4. Anything you can pass. Send. And if you go to the database now, in the book table, we'll see author 4 has 1 book, but author 1 has 2 books. Perfect. Now let's write the code to fetch all the books for a particular author. So let's complete that flow. So for that, we have to go to book repository and write a custom named query. Here we'll say return list of book entities and how we'll say find by in the book table there's an author, so we'll take this, copy this, paste it, make the first alphabet as capital, and then go inside this author and get this column ID and again paste it here. So now if we write query like this, it will automatically do the job for us. We'll pass the long author ID. So it will return us all the books matching this author ID will be returned automatically. So if I have to write queries based on other fields, so I can say find by title with T capital, find by description with D capital, find by price. I can write my own queries based on field names. Just I have to keep this in mind. So let's say I have to write a query to find all books based on title. So I can say Control D. Here I will just say title with T capital. I need to make sure I pass the title which it will search the value. That's it. So this is how simple the writing of query is. So now let's call this particular query from our service. So here we have the service layer where we say get all books for an author. So here we do what? We say book repository dot find by author ID and we'll pass the author ID. So it's going to return us a list of what entity? Book entity. But now we need to return book DTOs. So what we will do? We'll apply a for loop. We'll convert each entity into a DTO. Let's put it in a if condition. If book entities is not null, which means something should be returned, and book entities dot size is greater than 0. Only then do this. Otherwise, it doesn't make sense. Then we do a for loop. In this for loop, we will get one by one the entity. And then I need a book DTO equal to null. I will do book DTO equal to new book DTO. and do the conversion with bean utils. So I'll say bean utils dot copy properties, and I will pass in this time source is book entity. So I'll pass book entity, and book DTO is my object. But then we also need to add this list of DTO we have to send from here. So I will copy this list of DTO, book DTO list equal to null. And if it is here, we can make it as new. We'll add one by one this book DTO. At the end, we will return this book DTO list. All right. Now our service layer code is done. In the controller, we just have to create a method saying public. So now let's put it void, get all books for an author. We will just pass the author ID. So it will only have one request. So this URL will look something like this. And it should be a get request. So we will have get mapping. And the URL will be something like this, author/author ID books. Exactly same, but the method name is different. So we will not have problem. If we keep the method name also same, then Spring will complain ambiguous path. It will say ambiguous path. It will not be able to decide whether to go to this method or this method because the URL and method are exactly same. So you should have one thing different, either URL or method. So now we'll call the book service dot get all this, and then we'll pass the author ID. And this author ID, we will get it from the path variable like we got it here. Copy this. Cannot resolve symbol author ID. Why? Because we have two brackets here. This is the method. Why is it complaining? Strange. All right, my bad. Here I forgot to use the at the rate part annotation. Sometimes, yeah, you need to check. There can be silly mistakes also. So we say long, sorry, we will get a list of book DTO here. That's what we will get. And we simply create this response entity. But this time we will pass different data. We will pass list of books here. So this will change. And here the data will change. And also the status code will be just okay this time. And now we are returning the response entity. So the return type will not be void. Instead, it should be this. So let's quickly go and run this application and try to access it. So the application is starting up now. It started. Postman, this was the create book. So I will duplicate this tab. Just right click, duplicate, change to get. That's it, hit. So we saw in our database, we have only one entry for author. For author 4, we have only one entry, one book. That's what we saw, only one book. What if I change the author ID to one? Then I should get two books. Let me change that. So here I will change it to one. Search, and I got two books. See, one, two. Sorry. So this is how you can get books for a particular author. So let's quickly implement the rest of the functionalities that we have in the service layer. So in the service layer, we also have a functionality of search. So for the search, first let's write down the custom query. So what we will do is I will duplicate this, Control D. And what we will do is search will be by title. So we don't need this. If I don't write anything, I use this query for search. The problem here will be we need to pass the exact title, only then it will search. It will, if I pass this test title 1, only then it will search. Otherwise, it will not search. But what we want is we want to search on this title for any string, TIT, then it should search. TEST, it should search. 1, it should search. So we have to add this as contains also. So here we can say contains. So that contains or containing also. So we can just say contains. Rest Spring Boot will do. How do I know this? If I take this and Google, I will say Spring Data JPA. Spring Data JPA will give me all this. So it says with every field, we can create queries. Find by title, containing, contains, is containing. It. So we can have queries like starts with, we can also have find by title like. We also have queries like end with. We also have case insensitive. So I can say find by title containing ignore case. So I can go with that. Find by title containing ignore case. So I can say capital or small, it will work. So let's go ahead and quickly implement a search. So here, other things will be exactly same, just that the query will change. So I will copy the get books for all author. Here it will be find by this, and now we will pass this search text. So you can also write query on search on genre, search on price range, search on description, any custom field. And now it will give us the query books, and then everything remains exactly the same. The best part is if you wrote one flow, you can copy paste them everywhere. So I can copy this again and paste it here for search. But then what we will do is we will basically say change it little bit. So I will to show a different variation how you can pass data in another way. So I will say book search and change the method name to search book by title. And I want to pass data not in the path like this, Instead, I want to pass it as question mark, search term, something like that. So I will say @request param, @request param, or request param, and I want to pass string, and I will say query. So whenever I will pass something as query, that will be used. So I will copy this and paste it here. So this will be passed as a string to our search method. And now let's put debugger to see how this request param annotation works. Path variable we saw when we pass something the path, it gets populated. We can have one or more path variables. But request param is not like this. We do like this, and then I will show you how it will work. If we run our application, the application started. We have to go to books, search. So I will duplicate this tab, and it will not be this anymore. It's books, search, and here question mark, it's question mark, and then I can say query equal to, I can say TEST. I search this, it stops here, and in the query the value text comes, test, TEST, with also double quotes. So if I resume this, it does not return anything. The reason is we passed this test as in the quotes. I should not pass it. So now it will not come in the double quotes. If I resume now, it gave us all the things that are having test as the thing. But let's say I want some only 4. I want 4. The text title with text, the book with the title 4 in it. So it only gave 4. So you can even make this generic. So basically I can now combine the request param with path variable and path variable with request body, everything I can combine. So let's say I have to make this as more dynamic. I also want to make this search dynamic such that it can also search on, it is not only on searching on title, but it can also search on genre. So I will just copy paste this and I will say search type. And I will change this to search book, just search book, a generic name. I will go to this interface. I will just say search book. And here we will pass another string as, it's all logic that you have to apply, search type on what it has to search. And now we go to the book service. In this I say search book, that's it. I'm going to say string type. I have to go to book repository. I have to create more methods like control D like that. So let's say now I want to search on, now we were searching on title. I want to search on genre also. I will copy this, go here, and I will say this one as, instead of title, I will change it to genre. And this will become genre. Same way, I will go to description and then I will copy this and change it to description. You can also apply the same logic on the price description, and this will be description. And now what I will do, by very smartly here, I will apply if else logic in my, because service layer is for business, applying business logic. So what I will do here, cut this, not this one. This is our search. So we are making our search dynamic or generic. So it will be like this. So if I say if the type dot equals ignore case is D, which is description, then call find by description. Same way, else if the type is equal to, let's say, title, which is, let's say for title we can say T, then we can say do the same thing but with another method, find by title. And if nothing is specified, else just find by search by genre. Or we can even say else if type equal to type dot equals ignore case G, which is genre. So here it should be find by genre containing text. So this is, you can make these things dynamic. It's up to you. We can also here say if, let's say, they forgot, nothing was passed here. So if nothing was passed, we can, in Spring Boot, we have a mechanism to say what is, it can be, we can add something as default. So let's go ahead and do that as an example. So here in the controller, we can say if nothing is passed for, so here it will become search book, and the first parameter will pass as type, second this, and then here we can say default value. If nothing is passed, default we should use T. So if type is not passed, it will treat default as T. So let's restart the application and see how it's working. So it's also important to apply logic while developing any application so that you can save lines of code. Now with the same method, we can do all kinds of search. Otherwise, we would have to write each field, we have to write a search method. The more lines of code you write, the more chances of error or issues or bug, and the more your unit test also you have to write. So let's say if I don't pass anything and I search, directly click on search, you will see the type value will be default is T because it took from the default value on the request param, and the query was 4. So it will return us exactly what we were getting, 4. But as soon as I say question mark type is equal to G and the genre, let's say, is here, and I will search for test genre, let's say test genre 2. So now it will take the type value as not default because it's passed. So it will take G and the query is what we passed. So if we resume, it will give us only one which is matching on the genre field. this time. So this time it's checking on the journal. Earlier it was checking on title. Same way you can check on description. So you can make things dynamic like this. And here you can even combine path variable with request param and even on the body also if it is a get or post. We'll see an example now with put. So let's stop this and go for an update operation. So we will write a query to update our. So here is our query. Delete. So update book. So first, in order to update book, we need to find the book. So first we'll say book repository dot find the book, find book, find by ID, and then we'll pass the book ID. As soon as we pass this, it is going to return an optional of book entity. And now we will say optional book entity. And then if the book is found, let's say if the book is found, then we should say if optional of book is present, only then we will go for updation. So here we will say get the book entity first, book entity be equal to optional be dot get be, and then we'll set be dot set. Let's say we'll say genre as book DTO dot get genre. Be dot set title book DTO dot get title. Same way we'll say be dot set description book DTO dot get description. After we have updated the data in this, we will again call the book repository dot save and pass the same BE object, which is now being set with the new values. And this is going to return us again the updated BE. And what we will do is now we will say book DTO book DTO. We will basically say and we'll do a bean utils copy. And source will be this and book DTO. So we'll return the book DTO. So if we run this application now, this is updating the book with all the fields that will pass. But then we have to also write the controller, and in the controller we'll return the updated book also. So we'll say public. For now, let's say void update book. We'll pass two things. One is of course to find out the books. We'll need in the path variable, we'll need the long book ID. And we will also need the request body as book DTO. All right. And now we will have to annotate this method with @put mapping. Put mapping, and then the URL we'll want to update the books. So books slash colon which book. So book ID, which will get saved here, this name and this name. So it's going to update the book and we will pass the book in the body. And from here, we will just say book, we want the updated book. So book DTO 1 equal to, in fact, we can also assign the value here itself. So we don't need another variable. So we'll say book repository. Sorry, book service, where we will call repository in controller. Update book, and we'll pass the book ID and the book DTO. And other things is exactly same. Just create your response entity. And this time in the response entity, we are going to update the book. So this will be just taking book DTO. One object will get updated. And the book DTO is the data that will get the updated data, and will return 201 because it's updated or modified. So we can pass this. And here we'll change the response entity type to this. So now if we start our application and try to go and update a book detail, we'll see what will happen. So application is starting up. We go here. So this was our this is book. So let's say book/3. Let's see if the book with ID 3 even exists or not. So we have the book with ID 3. It does exist. So let's say we want to update the book. So let's change the path. So it should be 9,000, and it should be API/v1, and it's books/ID with a put mapping. And this is what we want to do with the book. We also want to send it. So we see now the book got updated to these things. We passed these values. So we did not pass the price. So price was not updated. Here we are not doing anything with the price, right? So price will not get updated. In the code, we forgot to set the price. So price was not updated, but other things got updated. If I go here, you will see book 3 will become updated. Run. See updated UP. The price did not because we forgot to add one line here. Let's add that. So be.set price to book DTO dot get price. That's it. So that will work. So this was about the full update. We updated everything. What about just updating one thing, book price? So just copy paste everything exactly the same way. And here, instead of these things, we don't need these things. We have the new price. So we will just set the new price here. And other things will remain exactly same. And we'll go to the controller. And here we'll copy this. We'll make this as a patch mapping. So it should not be put because patch mapping is used for partial update. So we'll say update price of this book. And while updating, of course, we have the book DTO, but here we'll say call the update price, and we will pass not the book DTO, but the get price, because that's what our service method takes. So update price. So now if we go and try to run this application and see if we are able to update the price. So it's similarly, you can have multiple patch methods for update description, update title, all those you can do. between single value you want to update. So you must have seen a form somewhere where you just update values inline. Sometimes you update your name, address inline, right? And then the backend is called from your front end for that particular value update by using patch. So here we have the patch, let's say, and then here we have the V1, we say 9,000. So if we call all the service, so we see here. So at this moment, the book title 3 has a price 2.99. So let's update that to price 9.99. Send. See, it returns with an updated price 9.99. Other things did not update. So if I click on here now, it should change to 9.99. Send 9.99. So now we are only able to update only one part. One attribute is getting updated. That's patch operations. See 9.99. Perfect. So now we are left with only one operation, that is deleting a book. So let's quickly do that. So deleting the book is very straightforward. So here we say book repository dot delete by ID. One thing I want to show. So you can even have count. So if you want to count how many fields exist, how many rows exist, all those methods are also existing. But for us, we just want to delete whatever is found. So we'll say delete, and by what? We want to use the delete by primary key, which is the ID. In this case, it's book ID. So we'll say we delete a book for a particular ID. So here we have the service. So we will basically copy this and then paste it here. And instead of delete patch mapping, we should have delete mapping. That's what is the HTTP method we should use according to REST standards. So books, and then everything will remain same. We'll say delete book, just pass the book ID, nothing else is needed for deletion. And we don't return anything from here. So we'll say void. So we'll say null. So here we'll say delete book and only pass the book ID. Get rid of this. It will not return anything because we have made it void. And here we will say void. Instead of created, we will say no content, because after deletion, nothing is left. So it should be no content. So let's run the application again and see if our application is deleting our book successfully. So starting up. So done. Now we'll go. Let's say we want to delete the book with ID 3. So let's refresh, connect. It's there. So now go to Postman. And we want to get rid of, so this is delete. So API slash v1 slash with ID 3. We want to delete. So it should be delete, and then it should be 9,000. If we send, it says 204, no content, nothing was written, but it gave us what we returned. So now if I do a get all, this should be gone. This should not exist anymore. So let's check the database first, run. So this third one should be gone. So it's gone, deleted from the DB. Same from the Postman also, we should not get the data. All books for author, search. So only two books, only one book exists for author one. That's true, this one. So this way you can also implement delete. Again, you can take this functionality to whatever level you want as per our requirements. Like this, we have order now, we can create customer, we can have relationship between them, we can create controllers, repositories and service accordingly, and we can build the whole functionality. One quick thing I want to show is now we were just building everything in the local profile. I mean, we did not had any profile. Whenever we were starting the application, it was saying no profile set. What profile means is if you are building application, you can have different configuration for different types of environments. So what you can do, copy this application properties, paste it here. And here you can say you will have a local profile. You can paste it and you can say there will be a test profile, dev, test, acceptance, and production. Acceptance and production. So you can basically now decide what configuration you want to run where. And in each configuration file, you can have different configuration. Let's say in this file. So first now we should get rid of everything from our. We can get rid of the main application properties file should be empty. We should not have anything here. Just one thing, Spring, we can keep Spring profile active. We can keep this value and we should give the name after this hyphen, like local, prod, test, acceptance, whatever we want, we can give. So I can say run this now in the dev mode. So if I start the application now, you will see it will say I'm running the profile application in the profile as dev. See, it says one profile found running in dev. Because I said dev, so it picked up the dev application configuration. But here also I am using the same database. But let's say I want to use a different database here, MySQL database on the dev, or let's say on the production, let's say. So here I will get rid of all this. I will add production specific configuration here, and I will go and change it here as prod. And in this file, I'm going to go and add production related configuration. So maybe I'll just copy it from there. But for that, we need to also have, let's say if I want to add a MySQL database in production. So I will type here MySQL in the Spring Starter. Here is the driver. It added here. So click on explore. Then search for where was the new dependency added. Here it is. Or I can even copy it from the POM here. That you can also do that. So here is the runtime connector. So there is a dependency for MySQL. For other database, Postgres and other, you will have different database configurations or POM. So as soon as you add it, click on this, it will build your application, download a new dependency, and we would need the Spring Data JPA configuration for MySQL. So for that, I will go quickly. Those configuration also you very easily get it from internet, so you don't have to remember. So in the test, I already have this. I'm saying the URL should be MySQL localhost like this, and there's the DB name. Username is by default root and password is empty. Again, this one is update. Show SQL true, and then use this dialect so that it will tell the Hibernate to translate our Spring Data JPA queries according to MySQL DB. So I copy this configuration and paste it in our production profile, let's say. But then I should have the Spring Data JPA, the MySQL database. So I have downloaded a server called XAMPP, which out of the box provides the MySQL database. You can basically also go on internet and download the MySQL database directly. You can say MySQL Workbench or MySQL database, or you can directly go and download XAMPP. XAMPP is a nice tool which has MySQL database embedded in directly. So go and download XAMPP like I have downloaded. You can download this and install it. And after that, once you install, you start the Apache and MySQL. So it will start your database like this. Create a new DB. Let's say I create here. I want to refer this as book author prod DB, production DB. So I will copy this, create a DB, create, and now it's done. And if I just now start my application in the prod mode, run it, you will see it will take prod profile and now it will connect to MySQL DB instead of. So it says one profile found, which is prod. And now it is going to also use MySQL. See, MySQL, it's using MySQL here. And if I go to the database now in the MySQL, I should have the entities created here. So if I refresh this, see author and book table. Of course, there is no author and no book here because I have not run the query. So if from the Postman, if I go and just hit the query for creating the author, it will create a new author, but in another database. Click. So now it has created an author here. So a new author got created. Same way, if I go and create a book now, it will create it into new database. So what do I mean by showing you this? That you cannot deploy your application in production with the H2 database, right? You need a new, better database. So how can you do development using H2 database, but deploy it into environment production or use it with a better database? Using profiles, you can do that. You can have separate files and separate configurations. So we have completed what we wanted to achieve in this class. Are there any doubts anyone has? If not, then I think we can close the class.
Sir, could you please share the video link, recording link?
Okay, I will share the video link and also I will share the code with you, the GitHub link, so you all can refer that and practice it there. Okay.
Okay, sir. Thank you so much.
Yeah. So thanks all for joining. Have a good day. Bye.